Okay, today we're doing Algebra 2 honors. We're going to be doing 5.6, the fundamental theorem of algebra. So for your warm-up, you were told to factor f of x equals x cubed minus x squared minus 22x plus 40, given that x minus 4 is a factor. So that being a factor means that I can plug in 4 and I should get a 0 because it goes in evenly, no remainders. So when I plug that in, I got x squared plus 3x minus 10, and then factoring that using a factor box, I got x plus 5 and x minus 2. So my factored form is going to be f of x is equal to this expression. For the new stuff, today we're covering the fundamental theorem of algebra, which states that if p of x is a polynomial of degree n greater than or equal to 1, then p of x, so whatever the polynomial is, has exactly n roots. Remember, roots is the same thing as solutions and x-intercepts, and then it's also in factored form as factored, including multiple and complex roots. So some of them might be imaginary, and then some of them might be irrational as well. So the degree of the polynomial will tell me how many solutions that there are. We've kind of been talking about that throughout. So without using a calculator, find the roots of each equation. Well, we have a couple of options. First option is to list the possible solutions, which would be positive and negative. This is my p, and then this is your q, which would be 1. And then this being over 1, all of my factors should be whole numbers. So I just need to look at the factors of 9, which are 1, 3, and 9. And then one guarantee I gave you from the previous lesson is if you cannot use a calculator, then 1 or negative 1 will always work. So I'm going to start with 1 because it's easier. And then my coefficients are 1, negative 9, and 9. And I'm hoping to get a 0 here. So I'm going to use my synthetic. And I'm going to put a 1. I have a 0. This will be 0, negative 9, and then I have a 0, which is great. That means 1 works. Now, at this point, I don't really need to do anything else. As soon as I get down to 3, I can always write it as a quadratic. So this is x squared. That's an x term. There's 0 of those, so minus 9 equals 0. And then I'm going to solve. I'm going to add 9, to both sides. Then I get x squared is equal to 9. I can square root both sides. Then I have x is equal to positive and negative 3. So my solutions are the 1 that we started with, and then positive and negative 3. Now, there is an alternative to this as well. And the alternative is to look at these right here. I see something special. I can factor this by grouping. Sorry. And so if I do that, I can group the first 2 and the second 2 terms together by way of review and see what we get. So these two both have an x squared in common, and I have left over x minus 1. These two have a minus 9 in common, and I have x minus 1 as well. It's not that you have to do it this way as well. It's just a good review of this method. And if you see certain things that look like, this could work, then try it because it's kind of a time saver, especially if you don't get to use a calculator. Okay, so these both have an x minus 1 in common. This x minus 1, this x minus 1. So I'm going to factor that out. So once it's factored out, this is gone and this is gone. And what's left? Well, left here is x squared, and left here is minus 1. So if I set each of those equal to 0, I know it looks like it kind of went away there. Everything did. I would have x minus 1 equals 0, and I would have x squared minus 9 equals 0. X squared minus 9 equals 0, we already solved. We know that it's x equals positive negative 3. And then for this one, this was x equals 1. So you get the same answer. Either way works. It's just I wanted to review that just for a moment while I have the time. Okay. So now we can use a calculator, and we're going to find all of the zeros of this polynomial. So what are your possibilities for these now? We need to list those. And this is your P, and then here's your Q. The factors of P over Q are all going to be whole numbers because the Q is 1. So I really just need to I really just need to have the factors of 20. So that's 1, 2, 4, 5, 10, and 20. The positive and negatives of all of these numbers are my possibilities. Then what I would have you do is to graph this on a calculator. So this is going to be, actually it's going to be y1, and then we need a good window. The smallest number here will be negative 20. So I'm going to give myself a little buffer and go negative 21. And then I'll go to positive 21. I'll go by ones. And then for the y's, remember, I just need to see a little bit of that. So I'm just going to always keep that as negative 1 and 1. Okay, so you're going to graph it on your calculators. Excuse the mess there. And you should get this. And so looking at this, it's kind of small, but it looks like it crosses right here and right here, which would be negative 2 and positive 2. Now, thinking about the fundamental theorem, I should have, because the degree is 4, just like for the last example, the degree was 3 and we had 3 solutions, positive 3, negative 3, and 1. The degree of this is 4, but I'm looking at this and right now it looks like these are 2 of my solutions. They don't tell me everything that I need, but they can help me get there. So going back to the original problem, we had y was equal to x to the 4th plus 3x cubed plus x squared minus 12x, sorry about that, minus 20. I am looking at that and I want to verify that x could be positive and negative 2. So let's plug those in using synthetic. So I have negative 2, and I'm going to use my coefficients, which was 1, 3, 1, negative 12, and negative 20. So bringing down, and I'm hoping this gives me a 0. So this would be 0. I'm sorry, just kidding. This would be 1, negative 2, 1, negative 2, negative 1, 2, negative 10, 20, and we have a 0. Now remember, makes our life a lot easier if we continue on. So I'm going to go ahead and continue from where I left off, and now I'm going to plug in 2. So I have 1, 2, this would be 3, multiplying I get 6, this will be 5, and then I get 10, which gives me another 0. This is great news for us. So where we're at now is we have x squared plus 3x plus 5, and then I'm going to solve this. Now looking at our graph, it didn't look like it passed anywhere in that range, so it doesn't look like it's going to be a real number, but let's check it out by using the quadratic formula. You have your a is equal to 1, your b is 3, and your c is 5. So x equals, go ahead if you want, you can press pause and then just check your answer, positive and negative. B squared is 9 minus 4ac, so minus 20, over 2 times 1, which is just 2. So x is equal to negative 3 plus or minus the square root of negative 11i over 2. Oh, just negative 11 so far. I got ahead of myself. Negative 3 over 2 plus or minus the square root of 11 over 2i. Now this is 2 solutions. The other solutions that we found already when we verified was positive 2 and negative 2. So there are 1, 2, 3, 4 solutions to this problem. All right, thank you so much and enjoy your day.